Hello and welcome back to Compiler Programming. Before we start to explain the feature, I need to remind you that one of the goals of this language and the compiler I'm writing is to provide a lot of flexibility for the programmer to express what they want, and that includes sort of both the semantic flexibility, as in which kind of data structures and types and so on you can express, but also syntactic ones. So that's why we have things like macros. So if we go to steady prelude, you can see like there are macros. There is a bunch of to-dos connected with them, but that's also something that I hope to address in the coming weeks and months. But the point is, you are able to specify new syntax for the program that you want to have, and then you can define these kind of program transformations, which is very, very nice. But one thing that is sort of missing right now, and that's something that is that makes Haskell-like syntax very hard, is the ability to sort of apply some kind of logic when you have two non-operator tokens next to each other. I know it might be a bit abstract, so let me try to grab some tests that we can start with, and then I will show you what's happening. And we would say something like, maybe it actually shouldn't go here, should go in operators. Yeah, I think it is part of the operator stuff, so let's put it here. And we would say should support defining a custom, I'm not even sure how to say this, token application, not application, token apply handler, I guess. I really don't know how to say, or maybe we should call it custom space or empty space operator, maybe put this in quote, empty space operator handler. So what do I mean by this? Well, if I have something like this, so foo42, in languages like Haskell, or I think Ruby also supports this form of function calling, so that would be actually equivalent to doing this stuff. I could just make it work like that as well, so I could go the Ruby way and allow just doing this, and that would mean a function call, but that is actually also very limiting. So what I want to do instead is I want to change the parser in such a way that when it sees two symbols that are not operators, it will try to find a function called I don't know, apply or something, because the thing is you can't even define this operator easily because it doesn't have a symbol, right? It's just empty space, and it can be arbitrary amount of empty spaces. I could try to normalize it, but the point is I don't think defining this as an operator is a good idea, and in fact I might even change how other operators work to be just aliases. But anyway, getting back to this point, so we have foo42, and I would like to be able to somehow define what happens when we have something like that. So let's call this parse empty space. I think I'll just call it apply. I think it's much more concise, and although maybe a bit more esoteric, I don't know. Let's just call it apply. And apply will be a function. Now there is an interesting question: what should it get as arguments? And I think a nice idea for this would be to allow people to easily match on these two tokens, but match on their types. So that means that we would try to, like if this is a literal, then this would be the type that we would put here. If this is a symbol, then this would be the type, I guess. So this is more of a kind of parse level concept rather than runtime one. Okay. So that means that here we need to somehow put a symbol, which is a bit awkward because we don't actually export it. So let's do as following. Mass is import mass. I probably should just support other quotes. Or maybe not. I don't know. Because this is a bit awkward in C2, right, with escapes. But that's not the interesting point. The point is, here we would say something like symbol is mass dot symbol, I guess. And then we would say that this is literal, and number literal already is exported, so I don't need to go to mass, like the compiler module, to get the definition for this type. I could just say literal is number literal. Okay, so that would be a function, and we can make it compile time. We don't actually need to make it compile time. We will automatically make it such. So, or yeah, I think we always will call this at compile time. Now, there is a good question of what it returns, because we don't really know. It would be nice if it could return anything, but I guess if it returns anything, we can just go through an implicit, which is something I added, I think, a couple of episodes ago. I will actually link it, I don't know where, there. Is it the right place for the YouTube notification? I don't know. I don't remember if my camera is mirrored or not. But right. So I guess as the return type, we should also say it is a number literal, and I'll just, yeah, what we can do is we can, for now, just say that we'll return 42, or we'll return the literal itself. It's not very nice. Like, it's not something you would want to have as a global thing, because no matter what you put into symbol here, it will always return you just literal. That's a bit strange, I guess. But for the test, that is perfectly fine. Okay. So then the result is correct. We still expect it to be 42, and we can try to run this test. Now, obviously it should fail because we haven't actually done the work, but it doesn't hurt to try to run the test and actually see it fail rather than thinking it will be failing. Okay, so it fails on line 333, so that's about the right place. Yeah, so it fails here. That is sort of correct. It cannot parse the expression. Right. So let's focus this test and jump in here. So this is the code sort of that is responsible for parsing expression. Let's bookmark it so we don't lose it. But there is nothing really fancy here. We go through each of the tokens or through each of the symbols, and then this is doing the matching of the macros. So the stuff that we saw over here, these kind of syntax definitions, this is the matching that is happening there. And After that, we just look at the symbol and decide if it's an operator, then we do something. If it's there is also a special case for function call, which is something that should actually be replaced eventually with what we are working on today, because you can imagine that like when I put 42, right? So that all that means that here we will have a like a group paren or something. It's called. So you have a symbol and then you have a group paren, and in here that means that we should just be able to call the function or do something special with this. But anyhow, we are doing this, and this is, I believe, the error that we are seeing. To actually verify this, let me go and quickly check how we are printing the error. Yeah, would be nice if we did this. So detailed message length, and then we are going to do the following. We are just gonna provide this message. Let's try the test again to verify that we are seeing the right error. And it doesn't seem to be the case, which is kind of interesting. So I guess I'm not understanding this correctly, because I would expect to see expected an expression, but in reality it is something else. Well, let's open up the debugger and try to figure out which error we are actually getting and where is it coming from. Right, that is a bit too wide. Okay, just a second. Okay, great, it finally happened. Now we can go to context error, something like this. Let's go to here, and this should allow us to know when we get an error. No, I don't want diagnostic tools right about now. I just want to know where are we. So this is the right error. Why am I not seeing the message then? This is a bit weird. Well, okay, I'm not gonna debug the error stuff because that's not really the interesting part. The more interesting thing is that we are in the right place and we can actually verify it by doing this. And no, I don't want the second event. No. Okay, test. This is what I wanted to do. Right. So we are in here. That's perfect. And this is where we then can add our handling. So how are we going to do that? Well, that's a very interesting question. So essentially we have this token handle operator, and I think we would have a special. Do we want to go through an operator route? That is an interesting question. Because the thing is, when you're parsing an expression, you need to make sure that you sort of apply all the operators up to the point where you're parsing. So let's say that I'm parsing this equal sign, and at this point I need to make sure that this is applied as an operator, so the arrow is correctly applied and the call is applied, and so on and so forth. I guess that would be the easiest way to handle this, even though it will be slightly awkward, but let's try it like this. So if let's invert this. So if previous is an operator, then we do the following. Actually, regardless of whether previous is an operator, we still want to push this value onto the stack, and then we will do this. And yeah, this is going to be our operator, which is just, as I said, an empty space. And this previous operator, actually, no, it's not an operator. So it is actually something like this. Right. If previous is not an operator, we do the dispatch. Otherwise, we do this stuff. Okay, that looks good. Now we actually need to create a separator, because if we run this code now, what we should see is we cannot find the operator empty space. Yeah, undefined variable empty space. Okay, that makes sense. And let me actually look at handle operator. So it tries to look up in the scope, right, and then it drains depending on the precedence and stuff. So that is kind of interesting. If last operator has less precedence than the current, then we are not doing anything. We're just pushing it onto the stack. If it is the same in associativity, we are also, otherwise we are, so only if last operator has basically greater precedence than the one that we're doing now, since empty space will probably have the largest precedence of all, we are never gonna get here, I guess. But right, let's see how we define this stuff. Okay, so we have this, and we have space. Now, this is actually a very interesting question of what should be the precedence of it. Like, if you have, let me show you. If you have foo dot bar over here, I think the expectation of people would be that you will get the result of this expression as an argument. So it will be sort of like this, and not like this. So this is just weird. So then that means that the precedence of this empty space operator is actually the same as the braces, and it will work out well when we replace braces with this stuff. Okay, so that's good. We can do mass handle apply operator, and we would look at this, and we can sort of copy this handle apply operator. Okay, so it gets the args. Fine. We have target. So in reality, we have left hand side and right hand side. We might not even need to unpack this now that I'm thinking about it. we can probably do the following. Const apply is scope lookup context scope apply, something like this. And then we just do this. It wants an args token and not an args view. That is a bit awkward, to be honest, but how do I go around this? Now, in reality, I might not even need to work to dispatch to function call directly, because I want this to be done at compile time anyway. So maybe a better option would be something like value view. Get rid of this code. That's not what I want to do. But in handle function call, we are doing this trick. Where is this trick? Yes. So this stuff, and this is basically what we want to be doing. We will create a fake eval view, and we also need fake args. I probably should create a nicer way to call a compile time function, but for now that is fine. We're just gonna hack it in, and then I can clean it up later. So the way this is going to work is we are essentially faking something like this. So when we get into here, what we want to do is compile time evaluate the following expression, which is like apply. Apparently I cannot write. Apply of left hand side and right hand side. So this is what we will be doing. So that means that we do like this, left hand side and right hand side, and we are going to put them here, and then we say token make symbol. I don't remember the arguments, but that's fine. Probably we need an allocator and slice literal this, something along those lines. Okay, so that takes care of the insides of this. Now we can do group fake parents is tag group tag parents, and then children is fake args, right? And then we have our apply, right? And we have fake parents. So this is probably it. I probably messed up a bunch of things, but we'll see. Missing semicolon, that's easy. Token make symbol wants more stuff. So it wants a symbol type and it wants a source range. Fine. we can do that. So let's extract source range so it is a bit easier to deal with. Okay. And maybe we will say value star comma is this, and that should make it easier. So we need to pass a symbol type. Oh, I think it is like ID, like, and source range. So something along these lines. And now in here we can do apply. It's basically the same. That's actually operator like, not ID like. And right, that's fine. Apply. Right, something like this. Let's try again. That's called paren. And then we need to make a value out of this. So value star paren value is value make context descriptor group and static average static of fake parents, and we need a source range in here as well. Okay, that even builds, but it is very likely that this is not what actually we want, but we'll see. Let's try to run the test and see it all crash and burn. Right, undefined variable bar. So right, that was probably not the right way to do this then. Let me think about this for a second. Here's the issue. So what is happening is when we try to evaluate that thing, where is it? This. So as I said, this is the same as evaluating left hand side and then right hand side. But the thing is, these are internal values, symbols. So when we make token make symbols, we create one of those values. And when we try to parse the arguments, we are actually sort of trying to parse it again. And parsing that means trying to look up the name, which is in this case the bar, and do something with it. So that's not cool. Right, so that means we somehow need to be able to call the function without resolving the variables. That is tricky. Tricky. Let me quickly think about it. So the problem is compile time eval, as I said, it will just eval whatever we pass to it. Right. I mean, I could do even greater hack. So what I could do is I could in here provide always the same variables and then define them to the arguments I'm passing. That is very hacky. So, but let's try to make that happen, I guess. So what we want to do is we want to create a custom scope here. Something like execution context apply context is context, or rather star context, and now we do apply context. Scope is scope make context allocator, and then context scope. So we are making a nested scope so that the new fake variables that we define don't affect anything else. Now we so now we need to use this context for here. Apply is fine, but in here now we need to do some funky stuff. So raw LHS and raw RHS, and then we need to do LHS ID is LHS, and RHS ID is RHS. This is gonna be ID like. Now we're gonna put this in here, and we are going to do scope define value context scope. No, okay, like this. Scope is context scope. Yes, that's a static value. Source range, name, slice literal. I think this actually wants a symbol now, so that would be actually kind of nice. And let's call this not raw but LHS value, RHS value, so left hand side and right hand side, and this ID, that's good. So something like this, and the same thing for the right hand side. Right. This is a one giant hack and I'm not very happy with it, but as long as it will get us to where we want, that is going to be fine. So to recap again, we are creating a new context, we are creating a new scope within the context so that when we define these variables, they don't pollute the previous scope, and then we define the variables with the right types, and we are trying to call this. Let's see how that will work out. Right. So apparently it does need just the name. That's fine. I can do just the name. That's good. Trying to overload on something strange. That is very interesting. So let's look at that error. what is happening here? Okay. Let's try this in debugger. I'm not exactly sure what's happening. Okay, so what is the overload? It's a scope. Okay. I think somehow this is wrong, but I thought that worked just fine. I mean, here it works just okay. So, well, just for test, let's try to do something like this here. Is it still gonna be the same? No. So it's perfectly happy to try to match it against this kind of stuff, but not against. So let's just do. I don't want to debug that part. Let's, if number literal works, let's try to do something like, I don't know, 2142. So if we have two number literals, we'll just choose the second one. Again, a bad function, but a perfectly fine test. Okay, so that actually works. Yeah, there is some kind of weird thing with. Oh, okay. I think I know what's happening. That thing is just not exported, and then we have a weird error. So we can try to fix that real fast and generate. Somehow I'm blanking on. Yeah, I want method.c, not generated. And we have a bunch of stuff here that is exported. So we just want to add this to this symbol. So export compiler, right? Export compiler. That sounds good. And we are doing this. So like this. I obviously need to make a better error, but that's not important for now. For now, I want to get this stuff to work. It is still very unhappy. Wait. Why did it say that everything is the same? Maybe I have some problem with regeneration. Okay, that's just weird. Now we should be exporting it correctly. Okay, anyway, as I said, that's not connected to what we are trying to do right now, so let's get back to this test, and I guess that is sort of about what I wanted to do. Of course, it is worth trying to run all the tests. And we actually have a few that are now failing. Right, so this is very interesting. So these tests, they were testing a bunch of parsing errors, but now they're no longer parsing errors. They will be overload errors. Let me show you what I mean. So previously, this would be a parse error because we were sort of like trying if true, and then we were looking for then, I guess. But what is happening now, I believe, is that we are getting like we are trying to parse it as this function application, or just not function parsing application, I don't know, empty space, and we are getting a different error, but we are still getting an error, which is, I guess, fine. Maybe what I should do is something like this. Let's see. What is the error that we are actually getting here? Yeah, okay. That sort of makes sense. It tried to apply it to... Yeah, so it tried to do if true, and that failed. So it sort of doesn't know what to do about this. It cannot find apply, and that is bad. Now, that's not the best error, so I need to think about how to maybe provide a better error, saying that if we can't find apply, then it's actually a parse error rather than regular. So actually we can do that. We can do that. So let's do it. It's the last thing that we do here, because what we can do is we can do value star scope lookup force. What is scope lookup force? Here. Context, that's fine. We can do it even before because that's a check, that's an error check. Context, module scope, no. Context scope, field symbol. So we actually want this here, and we'll say apply symbol is a nicer name for that. We will do this, and let's get source range in here and something like that. We probably don't want to do scope lookup force. We just want to do scope lookup instead, because we want a custom error, and if you do lookup force, it will just again say that apply is not found, which is not what we want. So what I want to do is scope entry, value, apply entry, right? And here actually need to do like this, and we say if not apply entry or apply entry tag is not scope entry tag value. So if either of those is not true, then we can say that stuff did not go well. So we can address right, and then return 0. And here we can say, well, we can return to previous message, so expected and operator. New, we actually want sort of the right hand side value as the actual indicator of where the error is. Right, so something like that. Let's try. I think that should actually fix the broken tests. Well, it fixed 2 of them. It didn't fix 1. Ah, right. That's because I have this new line that I added to see the error. Great. Well, yeah, that is, I guess, about all I wanted to do. I know it might not be very obvious what this should be able to do, but hopefully once I clean this up, I can make some more videos of what it enables. But to give you some future pointers, so one, as I said, is we should be able to call functions like this. The next thing is a feature that exists in some of the languages where you can do, I think it's called, how's it called? It's called like trailing block or something. I think in Kotlin it's called like this. So if you have foo x and then you have something like this, I don't know, 42, then it is exactly the same as if you would do, so it's exactly the same as something like this. So you sort of get lambda, or in some languages you get a code block here that is passed as sort of tokens or as a macro. But anyway, I think it should be possible to do both of those things with this new setup, but that is definitely a topic for a different time. Today was the basic feature, which is working, even though it is a bit hacky, but I'm pretty happy with the result. So if you stayed this far, I hope you saw something interesting, and thank you very much for watching, and see you next time.